Yeah, thanks for the introduction, and yeah, great that we have you here. We want to show you we call it pathway for megawatt charging. You may have heard or not heard. So megawatt charging is the next step for combined charging system or general charging system for trucks and buses. And I would like to show today a bit about what Charan has been done and also what is the result of the work and what it is good for. And also Semi will tell you about more details and what's technically behind it. So Charan is something like a man in the middle. Charan is supporting the connection between the energy side and the vehicle side. No matter what type of vehicle you can imagine shall be electrified, they all have to be charged. Yeah? And that's the key why we do electric cars and trucks and buses, is that we want to have renewable energy being charged in the mobile devices, let's say, in the trucks, buses, but also we're looking into the future for trains, but also marine applications, and we also can talk about mining applications. There are also big potentials for CO2 reductions by also bringing them onto the electric drivetrain side. And that's exactly what Charan stands for. And we're supporting also by developing and support of the developing of standards. And we're bringing the industry together to be able to align and to have a quick and easy solution for the markets. And for that, we have in the meantime a wide membership base. So Charan has about 325 members right now. And what you can see here on the chart, that has been grown in the last years very intensively and also around the globe. So we are a real global association. So we're not taking care about Europe or Germany. So we really want to have these charging solution standards being done on a global scale, but not only the pure standard, like you can see here, the MCS and CCS solutions. So we also want to have all the other type of solutions, like I had on the slide before, that they can also be used on a real global scale and around the globe, very unified, and that brings a lot of potential for cost reduction and for volume for everyone who is in the market. Okay, the car. Okay. How is 325 members of Charan looking like? So what you can see here, that we have a wide range of companies being part of the Charan community. So we have in the beginning started mainly with the OEM side, but what you can see now is that the majority of companies coming from other industry areas. We have right now about 100 EVZ manufacturers, and some of them you can also see here on the ICNC, and also all the other players are here from the CPO area, from also grid operator, energy, EMSPs, and what also is very important on the right-hand side here is testing and standardization. Because even if we have a standard being developed, it's always necessary to bring it appropriately into the products. Yeah? And these products have to be tested, and there's always some risk of new products, and we don't want to see them in the field. We want to have very high reliable and high quality and fully interoperable products, and therefore we are supporting the community by doing testings and testivals together from the vehicle side together with the infrastructure side, and that also takes care of all the communication protocols, but also additional features like plug and charge and also further services. But why do we need a new standard? I've already said MCS, that's what I want to talk about, but why do we need that? So the main thing is that if we go for further applications like the trucks and buses or mining vehicles, they have larger batteries. Yeah? So it means we need much more energy which has to be brought into these vehicles and ships and trains. So therefore we need also a higher power connection. And if you look on the second line, so if you look on the example of the trucks, there you can see that a typical long-haul truck has up to 600 kilowatt of or kilowatt hour of battery size, and this is quite a amount of energy. But it's important to be able to charge this energy during the typical break. So maybe you know that in Europe there's a regulation. It's different in different countries around the globe, but in Europe it's really clear that you have 4.5 hours driving, so the driver can drive continuously 4.5 hours, and then he has to stop for 45 minutes. So that means you have to have less than 45 minutes time to be able to recharge the battery of the truck to get again the range what you need for the next 4.5 hours. Yeah? So and if you make the calculation on that and also the charge curve of batteries and other parameters, you come to the conclusion that it goes up to 1 and up to 1.2 megawatt what you need in the peak for the charging event to be able to fulfill this overall requirement, so that you're really able to integrate a full electric long-haul truck into the normal operation mode with no change to the existing combustion truck or diesel truck behavior and drive situation. By having these requirements, we found out, or also our members found out, that there's no adequate solution available right now. We had at that time, and even now, we have CCS, and CCS was about 300 kilowatt charging power. We are now going to about 400, maybe 450 kilowatt with the CCS system, but it's not able to do that up to such a high current just by the physics. Yeah? So that was a really clear indication, okay, we have to do something to be able to bring also this power to the trucks and buses to have there a real reliable and full function solution. And what we did then, we had the community and the members of Charan coming to us and saying, hey, we need there a working group, and that was really then the key that we then did the learnings from the CCS development, the learnings from the field of the passenger car was being used, and the companies and the experts came together who did work on that. What was the aims and the target for that? What you can see here on the left-hand side, it's the existing CCS system. So it's a Type 1 and Type 2 AC connector, what you can see here. And then you have the CCS connector, also the Type 1 and the Type 2. So they are existing, and they are also continuously existing for the passenger cars and all the other applications. But then we see then the need, and that development has started in 2018, that we have now a definition of 3.75 megawatt for the MCS system, and physically is also possible to go up to 4.5 megawatt. And I remember very well the year 2018. I was together with other people in close to San Diego on a conference, and the first companies, and I know Daimler Trucks people and other came to me and said, hey, we have thought about it, and they came to the conclusions what we have on the slide, or had on the slide before. We need to do something. We need to do something, developing further, having a new system, a more powerful system. And that was the start of all that. And since then, we had then built up a team and a task force where then more than 100 companies from all type of the industry and also from different countries and different regions around the globe, also including with test labs, standardization organizations, but all the technical companies and all the logistic companies sitting together and working more than 3 years to develop the core specification of the MCS. And on the right hand side you can see then the requirements which were the core results of these discussions and of these development talks. And this list was then being used to define a first complete set of specification for the MCS. And from that basis, with a very much and completely aligned specifications, that it was possible then to really have a quick start of the typical very long standardization process where you need different standardization bodies for the different parts of a connector. I just show it here. That's just a comparison of the passenger car world on the left-hand side of CCS and the MCS in the middle. And that means that this is very important then to bring this knowledge from the whole group what we had into the different standardization bodies to be able to have there a quick development of the standard, and also to have a clear definition which is then able to fulfill the core requirements from the beginning of all that work. And I can say this work has been done very successfully, and I always have to thank all the companies you have been seeing on the slide before, which have supported very intensively with all the experts and over quite a long time to bring that to that status. And we are now able to bring that with the standardized products to the market. And that's a really big success for the whole community, and also for all of us, because that's then the enabler for all the different mobile applications, like I mentioned, not only for long-haul trucks, but also for buses, for mining trucks, for construction trucks, but also we think also for solutions for aviation, for marine, and also for mining. And to go in these details, I would then like to hand over to Semi, who can also tell you the details about that.
Yeah, thank you, Michael. So I will dive in more into the details of the MCS, and as you can see there, Michael already told you about the analogy to CCS. What we want to emphasize here is that we think that it is a safe and reliable system like CCS is, and it will be from the startup, it will be a safe system and reliable system, also with the help of the activities that Charan is driving. And let's have a look at the standardization landscape. So I think this overview is quite valuable to have a look onto the current status of the MCS development. So I show you here all the relevant standardization going on actually. The 5474-3 is, for example, the standardization for the vehicle side, and it's already been published in the mid or early beginning of 2024 this year. And we have the 63379, the connector standard, and it's going to be published end of this year. So you can already see a lot of different connectors in the field and buy them, and already have tests with them. So this connector standard is already quite far. We have the 61851-23-3, which is for the infrastructure side, and it's going to be published also beginning of early next year. And we have the 15118-10, which is for the Ethernet as a communication layer for MCS. So we decided together with the different standardization bodies, with ISO, ISC, and the SAE together, that Ethernet, to be detailed, the 10-base T1S communication layer will be mandatory for MCS. So this will be published also towards end of this year. And we are also, like I said, aligned with the SAE J3271 from 1 to 5, which will be published also end of this year. So what I'm basically trying to show here is end of this year, the MCS standardization will be ready and will be ready for the market to be implemented. And I also wanted to show you what Charin is doing within this activity. So we had driven a lot of different testings, like the connector testing that we have done together with NREL, the National Renewable Energy Laboratory from the US. And so we had done 4 kind of testing with different connector manufacturers sending their hardware into the lab, and they tested against each other regarding different kind of use cases. I will show it in a slide later. And we also had short circuit testings, which is very important in terms of safety. And we also had communication testings, so 3 of them at the University of Zwickau to ensure the reliability of the communication. So which is still pending is the basic signaling, which will be also done within this year. So looking at the testings that we have done, I already mentioned the NREL testing. So we looked deeper into so you can see the test setup, we looked deeper into the finger safety. So I saw there are 2 types of different MCS connectors you can have a look at, and you cannot put your finger into the pins, so it's quite safe that you will not get any injuries of it after the charging session, maybe directly. We had a deeper look into the fit and ergonomics. I already told you that we sent over, not we, but the connector manufacturers sent their connectors and inlets to the lab, and they did cross testings with the different connectors. And we also had like weight evaluations, temperature rise tests, and also current tests, so up to 3000 ampere of current flow with liquid cooled cables or inlets. And yeah, this is quite successful, I think. So with MCS having the capability of going up to 3000 ampere and 1250 volt of operating voltage, you are up to 3.75 megawatt of charging power, and with this range you can fulfill a lot of different use cases in the field of megawatt charging. So I think that is quite a successful product here. And I want to also show you the results of the communication testing. So I already mentioned it's the 10BASE-T1S Ethernet communication layer, so it's also safe and reliable system from the beginning on when this MCS is in market. So you can see the test setup here as well. So I'm not the communication expert, but for those of you who are interested in it, there is a report for that. If you are interested, then just hit me up and I can send you this report towards you. And you can also see the sponsors of this testing as well here. What I also wanted to show you with this slide is, Michael already mentioned it, so MCS just began with the truck history. So the truck manufacturers wanted to charge their trucks within a certain time frame, up to 45 minutes, whatever. But then we see, by having this range of charging power of up to 3.75 megawatt, we are also able to fulfill other industries like the mining industry. So we set up a task force where the companies are free to participate, so they don't even need to be a Charin member back then. And we created this task force, and we discussed the several requirements which is needed for the MCS for mining. For example, you have a dirty environment in the mines, you have a lot of dust and so on. So we created the so-called ruggedized MCS. So it has a metal housing. I also see Marc-André, he is the main contributor to that. So feel free to hit him up and point some questions towards the ruggedized MCS, and which also will be used also for the marine. So we will set up a marine task force within this year. So I think end of November. The kickoff date is not clear, but it will be also created for the marine industry. The marine environment is also a special environment by having sea water, or salt water, and having different kind of requirements needed for this application, which we will also consider here and point those requirements directly into the standardization of the marine industry. And as you can see, there are also a lot of different industries where we are pointing at. So we have early discussions with the rail industry. We see some other applications in the aviation industry. I mean, it's a long way to go because the batteries are quite heavy for the planes or whatever, which is flying. But it's a quite good use case for the ground vehicles to charge up within a megawatt range. So we also see first implementations there. Yeah, agriculture is definitely also one of these applications where MCS could be used. I also wanted to try to show that MCS, so try to show with this slide that MCS is a global approach. So it is not only a European or US related approach, so we have also projects going on in New Zealand with the marine electrification, for example, the project of ABB and Auckland Transport. We had very early discussions with them, and they decided to use MCS as well. And there is a lot going. I don't think that this is even representing all of the projects going on for MCS, but it's quite a well number. So we were at the Electric and Hybrid Marine in Amsterdam and saw the Shell dual-use charger there, where you can also charge your ferry with MCS. And we also see, for example, at the location of Watervee, they at the port of Long Beach, they have the truck charging site with MCS coming up. Also at the charging site, Electric Island at the DTNA location in Portland. So a lot of different applications already in the field. What Charin is also being involved in is the Horizon Europe project. So we are part of this project and proud to push MCS here as well by building a charging site up. I think one in Scandinavia and one in Netherlands. And yeah, there is also a lot going on in Scandinavia as well, and also in Spain. So yeah, that's it regarding some projects of MCS. And I wanted to highlight also some achievements that we have done with Charin. So basically you can imagine Charin as I always like to say, it's the glue. So Charin is bringing together the experts, and you can discuss with them about technical requirements, about regulatory topics, and point it to the correct institution. So what we have done is that we aligned, for example, for MCS on the vehicle inlet position. That's a major achievement, I think, because it's a problem in the field. You can see today with CCS that there is no, I mean, all of the different OEMs can put their inlet, charging inlet anywhere where they like. But in the field, if you are a customer and you want to charge your electric vehicle, and you see that the cable is not long enough, or you need to park your vehicle inappropriate at the charging site, then it's from the customer point of view, it's nothing quite good. So that is what we have aligned on in the working group for MCS. We had, like I said, the cable handling tests with NREL, the communication tests. We have a proposal for a construction site layout. You can see it on our webpage as well. And we also done some short circuit testing for the safety. What is still going on is the basic signaling I mentioned, and also a charging site recommendation for CCS and MCS. So I think it's a very important topic that we align here before the first charging site or MCS charging sites going into the field, to have a proper charging site for the trucks in the end. And there are also some safety topics like the inductance level alignment in our working group. I wanted to show here some already available products, just here at a glance. I already mentioned some connector manufacturers. They have a lot of products, so you can see all of them here. These are already available. So we have already some trucks. Unfortunately, there is no truck here this year at the ICNC. Last year, I remember there were MAN, but we have also Mercedes, we have Volvo going on the US side. We have a lot of different OEMs going on with their MCS trucks, like Nikola, for example. And yeah, I'm looking very much into it for the progression of products being into the field. Especially towards end of this year. So I think the first products will be ready towards end of this year. And yeah, so that's the end of my presentation. And I would like to have a discussion with you if you have any questions towards us or any comments that you would like to know about. And yeah, so that's it. Thank you.
Yes, so thanks for your kind attention, but we are here also to answer your questions. So any questions for us regarding MCS, regarding Charon?
Andre from Zurich. How can pilot projects be done before it's published? How can MCS be done before it's published?
Yeah, that's exactly why we want to have all the companies involved in this process. So they are involved, they are part of the development of the specification, they are part of the development of the standardizations, and there are a lot of formal things to be taken care of during the process. And yes, it's sometimes a risk to start earlier before the standardization has been completed and the standard is published. But if you as a company are part of the task force of Charon and taking care that the specification is done properly, you are also a bit in front of the situation of other competitors that you can start with your development. There may be some adoptions at the end, but you can already take that into account and can do the products. And though that's also what companies did, and you have seen several announcements like in Sweden, in Munich, and also what Semi showed of pilot projects which are already around the globe showing that it's working, and they have the first serial products also on the road. Yeah, and it's good to have that. Yeah, because the truck business and the logistic business is one of the key parts what we need to electrify to reduce the CO2 emissions. Yeah, it's much more important than passenger cars, but it's much more work to do. But I'm very promising in the expectations how that will be done, because if the battery costs go down and if we have a good, reliable infrastructure which is also supported, especially in Germany with, for example, the HOLA project and other projects, that we have infrastructure and enough charging stations for trucks available, that this can be done a really quick development. Yeah? So for the truck business, they are the logistic guys. They count every cent per whatever unit, and if they come to the conclusion it's cheaper, yeah, because of the overall reduction of cost, yeah, less maintenance, longer running times due to the electric motor instead of a combustion engine, then the market will quickly change, and then it's just a question how quick can we install the chargers in the roads and on the parking stations, how the market will develop and will change for electric trucks. Yeah. Further questions?
Hi, thank you. Diogo Freitas from Galp. A quick question on a follow-up to your answer, that is, what do you guys believe will be the biggest push towards the electrification of like heavy-duty fleets and things like that? Will it be mandatory laws? Will it be the fact that those companies, customers will demand zero carbon deliveries? What do you guys believe will be the biggest push for this electrification?
Yeah, you already mentioned a few of them. There's for sure regulation where you have to fulfill CO2 targets, either from the OEM side for the trucks, but also for other industries. They are different depending on what region in the globe you're looking at. There's also further cost reductions like the maintenance. Yeah? But I think the key factor is really if there is the energy available in a way that the total cost of ownership by reducing cost of the battery systems, and this is already happening, is going to the break-even point so that it's useful to buy a more expensive electric truck and save the money during the operation of it. That is the key driver. Yeah? There right now is more regulatory push, but the next big step is then really when we hit the break-even line. And depending on who you ask, this break-even line will be between 2025, 2027, depending what calculation you make. But that's what I hear from the market. And if that's happening, then it's only a question, are you able as a logistic company to drive full electric on your roads, on your tour you want to make? And if that's done, then the next blocking point is away, and then you will see a quite intense growth on that. And it's always then, what I mentioned, limited to the availability of charging stations, and that's similar to the passenger car, but there it's really more calculatable because you have clear routes, you have clear timings, when is the next stop, how much energy is needed, what power is needed. So it's much more plannable, much more predictable, and that's why I think there's a big chance that also this is going hand in hand with the truck business. Yeah.
Maybe to add a couple of words, also the technology side. So I think we all hear like from week to week news about the battery technology. So I think as soon as we have the right battery technology coming up and providing either more range or less battery costs, then you will have the break-even point coming to have MCS implemented, or the trucks getting electrified more and more. So that I wanted to add here. All right. More questions? All right.
Maybe one question from my behalf. What about MCS, but automated connection device MCS, or no? Does it?
Yeah, we're also talking in the Charan and the different focus groups and tech groups about automated charging. There are a lot of different. Maybe I wait a bit. Okay, thanks. There are a lot of ideas how to automate charging, and one is the inductive charging. We all have seen in different prototypes for example, also buses, but also for taxis and all the other things. And this is not fully decided how the market goes. Yeah? It's for sure an improvement of customer comfort, but it costs money, and this is something which is difficult to make it a business case. There's for sure a luxury high-class segment where it makes sense, but if you look on the aspect of if we have in future also automated cars and trucks, I think this is then a must-have. Yeah? But right now it's still a question, what solution will be developed appropriately? Is it, like I said, wireless charging? Is it automated connection charging? This is all developed right now. Yeah? It's also on the level that we want to standardize it globally and unified. So there are a lot of work has been done in the last years, but it's still not fully aligned. So there's still more work to do, but it will be also continued. And then we will see how it will look like when the real market demand comes from a technical or commercial side. And this for sure will happen when we have the automated cars or trucks being running around, because there it's really necessary then to improve and to use this solution with electric trucks and cars to have this automated. Yeah? Without that, it would not make any sense. Yeah? So that's a must-have then. But we are not yet at this stage, but we are prepared for that, and our community of Charon is prepared and working on that.
All right, thank you very much.
Yeah, just to add a couple of more words. It was shown in the requirements slide here, that's why I brought it up again. So it was from the beginning on designed to be automated. So that is the purpose here of this slide. And like Michael mentioned, it is in some use cases it will be crucial to have also automated solutions with MCS.
Thank you very much. Are there any other questions that anyone would like to, any topics anyone would like to address? I guess that calls it a...
Yeah.
Yeah.
Thank you very much.